Hello, my name is Samier Mukhashen, and I'm going to be going over the Iterator design pattern today. So let's go over the basics. The Iterator design pattern is a behavioral pattern. Its intent is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. An aggregate object is an object that contains other objects for the purpose of grouping those objects as a unit. Basically what that's saying is an aggregate object is a container or a collection. So like in C++, those would be linked list or a vector or hash tables. The motivation of the iterator pattern is it allows you to access elements of a list without exposing its internal structure. So say you have an array, a linked list, and a hash table all in the same program, and you want to traverse through them easily. The iterator pattern can help you do that. It's supposed to separate the algorithm from the data structure. It takes the responsibility of traversal out of the list object and gives it to the iterator object. So here's the relationship right here. What's gonna happen is you're gonna make a list, and the list can count, and you can add to it, and you can remove elements from it. And then you're gonna make a list iterator, and that will hold the first position as well as iterating through it with the next. It'll tell you when you're at the end of this list and what you're currently on. Here's the structure. So what each part is the aggregate, which is the container. It defines an interface for creating an iterator object. The iterator defines an interface for accessing and traversing through the elements of that aggregate. The concrete iterator implements the iterator interface, as well as keeping track of the current position and traversal through that aggregate. And the concrete aggregate implements the iterator creation into the interface. That is basically what I just said, so we're gonna skip over that. So the consequences are it supports variations in how you go about traversing the aggregate. If you ever want to change the traversal algorithm, you just have to replace the iterator instance with a different one. It's that simple. It simplifies the aggregate interface. Everything is nice and clean and there's no clutter, since the statements themselves are pretty simple to implement. You can also have more than one traversal going on at a time. An iterator keeps track of its own traversal state. They're all independent from one another. So you can have different instances going on. You can have one traveling through this list while another one's traveling through another list. Consequences continued. It provides a uniform interface for traversing through different aggregate structures, and this in turn allows a polymorphic iteration. Iterators have many known uses. They are very common in object-oriented systems. Many of the languages we use, such as Java, C++, C#, Python, PHP, they all have some library built in or something close to it. Here's some more examples of iterators. Some more examples of popular iterators. Not going to name them because you can clearly see them. So, summary of iterators, the iterator pattern. You can access elements of an aggregate object, a container, sequentially without exposing its underlying representation. You can have multiple iterators going off at once. They're all independent of one another and hold their own information on where they're going and where they are currently. And they're much better than index-based element access because it hides the implementation. The original implementation doesn't need to be brought into account when you're using the iterator pattern. Alright, so let's look at some code. So here's my code, my lovely code I wrote in C++. Here is everything I included to make the iterator work. Here are the various aggregate objects that I'm going to be using the iterator on. First, I'm going to display how we would normally do it without an iterator, so we have something to go off of. I started by making an array of strings. It can hold 10. Its name is fill me, and inside I have this is a test to see what happens. Now the way we would normally iterate through this is we'd use a for loop, and we would see out what's at every position using the index right here. Just go from 0 to 10, I++, and then we spit out what's in there. So let's see what happens. Ooh, big shocker. This is a test to see what happens. So nice and simple, yeah, that's the way we're used to it. So the way to do it with an iterator, just push this down over here, is you're going to initialize the iterator over here, and the way you do is by doing this bit of code right here, and then you name the iterator. So the iterator, I'm naming it array it for array iterator. And then we're also going to use a for loop to go through it. We're going to start at the beginning of fill me. We're going to go through until the end of fill me. And then we're going to array ++, array it. And then we're going to see out whatever's at that current position. So let's see what happens. There you go. This is a test to see what happens. So these little spaces here, because it's an array of 10 and I don't have 10 objects, so it's just spitting out the spaces. So if you were to do this, it goes all the way until it hits a null. That's what end means. And then it just starts spitting it out. Now you can also do this with a vector. Let me show you. I made a vector, initialize the iterator. I pushed in a couple numbers because it's a vector of ints. And notice how the code, let's see, is exactly the same for both of these. Just initialize, you start where you want to start at the beginning, all the way to the end of it, and you cycle on through. And you see out whatever's in it. So you should see out 1, 44, and 633. We got 1, 44, 633. Beautiful. Now one more case. A lot of these standard libraries, they also have, I don't know, like not quirks, but other ways you can iterate through, such as here in C++ in the list you can call a reverse iterator, which is, shocker, it goes in reverse of whatever's in there. So I made a list of strings called a journey, and I'm going to push in these different names. I pushed it in separate ways: open arms, don't stop believing. I pushed it in that way, but we're going to start at the reverse, and until we reach the reverse end, which would be the beginning, we're going to see out what's in there. There we go, look. See? It started with don't stop believing, went to open arms, and went to separate ways. That's the way you use an iterator. In Java, in all different languages, it's basically the same way. It's just the way you define it. And iterators are really helpful and useful. Thanks for watching.